We want to solve 2 cosine squared x minus 1 equals 0. So we want to isolate the trig term. So I'm going to add 1 to both sides. That will give me 2 cosine squared x equals 1. Then I'm going to divide both sides by 2 to get the cosine squared of x as a half. Then I'm going to take the square root of both sides, noting that when you take a square root, remember you have to say plus or minus the square root of that. So the cosine of x is equal to plus or minus the square root of 1 is 1, and the square root of 2 is the square root of 2. So if I look at my special right triangles, I have a problem in which cosine, which is adjacent over hypotenuse, is 1 over the square root of 2. That means that the third side of this triangle would have to be 1, and theta is 45 degrees, which in radians is pi over 4. This particular problem, if they had asked me to find the answers between 0 and 2 pi, would have 4 solutions because of the plus or minus. There are 4 quadrants in which cosine is positive or negative. So my first quadrant answer would just be pi over 4. My second quadrant answer would be pi minus pi over 4 using the rules we learned for reference angles, which if we get a common denominator would give us 3 pi over 4. My third quadrant solution would be pi plus pi over 4, which if we get a common denominator would equal 5 pi over 4. And my fourth quadrant solution would be 2 pi minus pi over 4, which if we get a common denominator would end up to be 7 pi over 4. So if this had asked me for the values in between 0 and 2 pi, those would be my 4 answers. Since it didn't restrict the domain, then I want to look at all the values that would be true for this. So I can go back and add plus 2n pi to each one of these answers to get my final solution. Now, because these values are repeating every pi unit, another way we could have written our answer is just pi over 4 plus n pi and 3 pi over 4 plus n pi, and that would have taken care of our other solutions in the third and the fourth quadrant.